Hi, I'm Damon from ProtoFab and I welcome you to our YouTube channel. The 3D printing and prototyping industry has been accelerating at an immense speed during the past few years. We here at ProtoFab believe that it's time to go beyond dimensions of just providing printing services and manufacturing 3D printers. Additionally, we want to use all our resources and provide you guys out there a more in-depth and transparent look behind the scenes of industrial 3D printing. So for this video, I will guide you through the complete workflow from file to finish of this beautiful steering wheel. Shoutouts to Legion for his beautiful steering wheel design we found on GrabCAD. Make sure to check out GrabCAD. It gives you access to nearly 3 million free CAD files, and they even offer an amazing online 3D tool with lots of useful functions. Link is in the description below. The first thing we need to do is import the STL file into the additive manufacturing software, for example, Materialize Magics or NetFab from Autodesk. This file is usually provided by the client. Our technicians analyze the model carefully and look for any optimizations that might be required. These adjustments are usually tiny but will make the printing process more efficient. This particular wheel that we are working on requires 2 drainage holes to be added. This is because we want the inside to be hollow so as to keep it nice and light. If the wheel was printed completely solid, it would be excessively heavy and much more expensive. If the part was printed without these holes, uncured resin would remain inside the hollow sections after printing is complete, which is obviously not what we want. However, we also don't want there to be holes in the finished product. So, we need to cut out 2 holes, but we will keep these circular parts and print them separately as hole covers, which will be fixed on after printing is complete. Next, we have to generate the supports. It's essential that the part remains perfectly rigid throughout the entire print, and therefore we need some support structures to make sure of this. Most parts are printed at a tilted angle similar to what you see for this wheel, as this makes it easier to support. A more upright or more horizontal print orientation would require much more support material to be printed, which wastes time and material and complicates post-processing. You might wonder why we are building the support structure on the front instead of the back of the wheel. The main reason for this is that it allows for easier and cleaner post-processing. Normally, the supports would be used on the side that is seen less. But in this case, the back of the wheel is covered in small indentations, which would be disrupted by the support structures. Fixing this in post-processing would be time-consuming, so it's easier just to place the supports on the front. Nowadays, modern software is very good at calculating exactly where these supports should be placed and exactly how many of them are required, but there is still some manual input necessary. For example, after the software has generated the supports, there usually needs to be a process of fine-tuning, which is based on extensive experience. Our technicians will instinctively know if certain sections are likely to be under-supported using the software-generated supports, and will beef up the supports in those areas if necessary. They are also able to spot areas where the software has been too conservative and is using a needlessly large amount of support material. This skill is difficult to teach and comes from many years of working with 3D models and 3D printing, experience that the staff at ProtoFab have in spades. And the free training we offer our customers is quite sought after. It's not just the part that needs to be supported. Sometimes the supports themselves need extra support to make sure they remain completely rigid, especially during the early part of the build when they are only partially formed. Remember the hole covers I mentioned before? They need support too, otherwise they would just be floating in the tank. For parts so small and light, this is a much more straightforward process, although as you can see, it still requires manual input from our team. Last step, slicing. The part is now sliced into layers based on the chosen layer thickness. Even though our printers are capable of printing a layer thickness of 0.05 mm, we normally use 0.1. unless otherwise requested by the customer. The reason for this is that 0.1 mm is already very accurate and fine. 0.05 would mean double the print time and an increased cost. In this case, the whole part, including supports and the support base, consists of 3,385 layers. Now that the 3D model is complete, it's time to start preparing the printer. No matter the size of the part, the resin tank always has to be filled to at least 95%, otherwise the print software won't allow the print to start. At Protofab, we use our own resins which are created specially to work best with our hardware. We have a wide range of materials available, and choosing which resin to use is an important part of the process. In this case, we are using Formula L1 ABS-like resin. The surface of the resin needs to be completely flat, so there can't be any bubbles or foam. Surface bubbles are skimmed off manually using a special tool, a process that needs to take place after the tank has been newly filled. After this, the resin is then leveled through a pass of the recoater blade. The tank contains sensors that detect any movement or unevenness on the surface of the resin, and printing can only take place when the resin is absolutely level and still. While the printer and the resin are being prepared, the operator checks over the 3D model. Here we can see a simulation of the part being built up one layer at a time. The engineer is checking whether the part will be rigid at every instance of the build. It's all very well for the finished part to be completely stable in the tank, but it also needs to be sufficiently supported even when it is only a few layers tall. If a part deforms by even a fraction of a millimeter at the initial stage of a print, this tiny discrepancy will be amplified more and more as the print goes on, translating into a very large discrepancy by the time the part is finished. So it's critical to get the supports right. Generally, the design produced by the 3D modeling team will be fine, and this stage is just about the print team gaining a close understanding of what is to be printed. With the 3D file now fully confirmed, it's time to transfer it to the printer using a USB stick. It's at this stage that the final orientation of the part is set. This step is often overlooked and can impact print time significantly. If you'd like to see a video on this specific topic, you can let us know in the comment section below. Now we can finally start printing. After each layer is cured by the laser, the build platform moves down by the height of one layer and the recoater blade completes one sweep of the surface. Once all the layers are complete, the build platform rises back to its original position and the finished part emerges from the resin. This is probably the most dramatic part of the entire process and is fascinating to watch. We then need to prise the part from the surface of the platform with a scraper. Only the support material is in contact with the platform, so there is no need for an excessive amount of care. Scraping or damaging the base isn't an issue. Once this is complete, we then remove the part from the printer and take it to be washed. Washing takes place in a highly controlled environment and full safety equipment must be worn. There are 3 alcohol baths in total, and parts need to pass through each of them. In the first bath, the part is simply soaked in the alcohol, which removes the bulk of any excess uncured resin from the surface. Care is taken to ensure that each area of the part gets a good soak. We can then move on to the second alcohol bath, where the part is brushed with the alcohol to help further remove any residual resin that is still on the surface. At this stage, the bulk of the support material is broken off by hand. These support columns are designed to be removed so they come away quite easily, and the alcohol helps this process. However, the support material will usually not come away completely when removed by hand, so some scraping and sanding will still be necessary later. Now we can move on to the third bath, where more brushing takes place to try and get rid of some of the remaining support material that wasn't snapped off in the second bath. For those difficult to reach places, an air gun can be used to dislodge any remaining excess material and also help dry off the alcohol. The whole part is blasted in this way. The more stubborn support material must be removed by hand. This is done using chisels and other tools and sometimes has to be performed fairly aggressively. Once this is done, a first round of sanding can take place to smooth out the worst of the rough patches. There are several rounds of sanding still to come, but right now the resin is still too soft and care has to be taken not to apply too much pressure as it might deform the part. This is just a preliminary sanding to prepare the part for post-curing and get rid of any tiny parts of the support structures that are still present. SLA printed parts generally need to be post-cured in a UV oven. This is because polymerization of the resin still isn't complete at this stage, and the alcohol bath, which made it easier to remove the supports, also softened the part itself in the process. Now it's time to move to the paint room for more sanding and the first coat of paint. At this stage, the small hole covers that were printed alongside the wheel are inserted into their respective holes. Once the paint is applied, the joins won't be visible. Painting is performed under laboratory conditions and full protective equipment must be worn at all times. This is both to protect the health of staff and also to ensure a sterile environment, so there is no contamination of the paint surface by hair, dust, or other foreign bodies during this phase. The part is first sprayed with a dark undercoat. At this stage, the color is irrelevant. This coat is all about preparing the part for sanding. The removable buttons are also covered in this undercoat. Once this has been applied, an extensive round of sanding needs to take place. This is thorough to the extent that the first coat is almost entirely removed. In our case, the steering wheel was sanded for 4 hours. This ensures the surface is perfectly smooth and prepares it for the second round of painting. Now the next coat can be applied. This is still not the final top coat. It serves as a base for the further colors that need to be added. The spray paint used is incredibly fine and great care is taken not to produce any bubbles or unevenness. The buttons are also given the same coat to prepare them for the next round of painting. Once this coat is complete, it's time for the final colors to be applied. This wheel uses 3 different colors: black, silver, and brown. When the silver and brown are being applied, the other sections of the wheel need to be covered in masking tape. This is a fiddly task that requires great patience and precision. A millimeter or 2 off and paint will be applied to areas where it shouldn't, spoiling the overall finish. Here we see the part fully masked and ready for the silver paint to be applied. The unmasked section around the edges will also be painted brown, giving a 3-tone finish. Once all the painting is finished, the silver buttons will be affixed and the wheel will be complete. So, this is it. Job well done, I would say. If you have a project you'd like to get a quote for, make sure to visit our website and contact our sales team. The link is in the description below. So this is it for this video. If you enjoy our content, please press like and subscribe. Anyone who does that and leaves a comment in the comment section below might have the chance to win this beautiful steering wheel. Thank you very much for watching. I'm Damon from Protofab, and I will see you next time.